analytics. And then there is a machine learning scientist who knows a lot about predictive analytics. If both the people don't work hand in hand, they are no way going to make a very good predictive model. So domain knowledge is very, very important. And that's what is represented by business understanding here. So that's the first part. So you cannot do away without a business knowledge. Second step, as you see, is data understanding. So data understanding comprises of actually what are the different data types that you require to build a predictive model. So let's take an example. So when you do natural language processing, let's say, yeah, go ahead.
Are you going to share the slides?
No.
So I'm taking pictures.
Yeah, go ahead, take it. So, and I mean, I'm booked under IP, so I cannot share anything that I talk. I mean, you can take video, photographs, whatever, but I'll not officially give you anything. So, data understanding focuses on what are the different data sources, what are the different data types, what kind of data is useful for my model. So, I was quoting an example of if I'm a fraud analyst, I work for CIA and I'm trying to figure out like which are the countries who are trying to attack America. Let's say this is my fraud model. That's what I want to predict. Like which are the countries that can like attack America, and I want to build triggers that whenever any kind of indication happens, I'm notified for it immediately. So there could be CIA experts who have worked in this field for several of years, and they have data, so they know, okay, if I see a different kind of air pattern, like a lot of air flights are coming in, if I see different kind of demographic of people who are coming into the particular airport, going out of a particular airport, if I see a lot of banking transactions happening to a particular specific country, those are the indicators for, because this is a CIA analyst, like you and me might not even know that this is a data I need to look into to determine whether some country will be attacking US or not. But for a CIA analyst who has spent several years in this field, for him, these are the data points he will be focusing on. I'm just using this as a hypothetical example, not that I know what CIA people do. It's just for an illustration purpose. Now, this person has business domain knowledge about what are the key indicators. So in business, we use key performance indicators like to determine whether the business is doing well, is it successful or not. Same way, this person will determine key indicators to build a predictive model. And now this person may not be a computer scientist, this person may not be a mathematician, may not be a data scientist, so he will rely on a person like, suppose, me, or the people. Yeah, go ahead.
Well, it all seems to be like human suspicious versus real data-based knowledge.
Yeah, I think that's a very good point. So
you might be completely wrong, and if like a lot of people of a certain nationality located in one city, this country gonna attack this city.
Yeah, which is right. Yeah.
Unless you can prove it with data, that's like a bullshit.
Yeah. I will strike off the last comment that you made, but I think you made a very valuable comment before whatever the last word you used.
Whatever.
So yeah, I think it is very right, and that's the beauty of any kind of predictive model. So we have a terminology of false positive and false negative. We'll talk about it later in the slides. So, but that's a very good point. And that's why we say, so computers can only do something that we tell them to do. They will not do something that we don't tell them to do. So if we ourselves are feeding wrong information to a computer, we cannot expect it will do something superbly great. So that's the analogy. So any kind of an expert system or a predictive system is only good as the data that you feed into it, and also the person who is operating it. So sometimes people get confused that, hey, I'll have a predictive analytics system, expert systems are built, we can remove human beings. That's the biggest mistake people do. It cannot eliminate human beings. Human beings are required. I'm a complete fan of human beings. So moving on to next. Did you have a question? No? Okay. Data preparation. So data preparation is, let me take an example of the CIA example is very good. Actually, I just formulated it right now. So they want the banking transactions that are happening across US and different countries. So they might have profiled certain countries like North Korea, or let's say some other countries I'll not name, like Iran or something like that. If they see a lot of banking transactions happening to and fro from US, they want to track that kind of data. Then they want to track the profile of people entering in, let's say, Washington State. Washington DC state, not this Washington State. And they want to see what kind of profile of people are coming. They want to profile this data. They want to even profile the data, what these kind of people are talking on social media sites. And they also want to profile the data, what kind of charity donations are going to these kind of countries. So these are all different kind of data types and coming across from all these different sources. So data preparation becomes the next task. Once you have identified which are the data sources from which you will collect the data, now you want to build systems to collect the data and aggregate them together, right? So that's the next step, data preparation. And during the data preparation, what you do is that you collect all the data and then you put it to a system, predictive analytics system, that will build a model for you. So you gather all this data and you train the data. So you train, and outcome of the training processes is the predictive model. And this predictive model will predict you based upon new data that comes in, whether it is true or false, whether this will lead into an attack or not, that kind of a binary answer. It can also come across as a multi-level answer, like you may not have always a binary outcome, you can have like 10 different outcomes. Tell me what is the probability that the attack will happen in next 1 month, next 2 months, next 15 months, next 13 months. So these are the 4 different outcomes you may want from the system. And it can come with, I think the next attack would happen in the next 3 weeks or in the next 5 weeks. So that's the kind of outcome that. So you can have a binary outcome, will an attack happen or not, or you can have multiple kind of outcomes based upon how you configure your data. And next step, as you see, is evaluation. Evaluation is nothing but when you know what the outcome is. So if I know based upon past history that these were the countries who tried to attack on the US, like Japan or Germany in the past, in the World War I, World War II, what not. If I have this data which has already been validated by time, I'll try to predict the same data from the model. And if the model comes out with the same answer, I know that model is working fine. If it doesn't come out with the same answer, I know it still needs to be worked. So that's the way you evaluate a model. And finally, if every evaluation is working fine, data is fine, really taken time, you deploy it. And then this process kind of spirals across. You keep doing, feed new data, update your model, keep going through the same process again and again. Yeah, go ahead.
Oh, how would you get, because I see the circles going around.
Yeah.
But after you deploy it, how do you get more business understanding?
Yeah, so that's a very good question. So this is a machine learning system, right? Learning increases over a period of time, right? Is it would you think it is an accurate statement? So if that's an accurate statement, what happens once you deployed your system, you will keep evaluating that how many times your predictions were accurate. So suppose I said tomorrow it will rain in Seattle, right? Now when the tomorrow happens and it doesn't rain, you know my system didn't perform well. So that's new information you learned. You can feed this feedback to the system, right? Update your model. So when you are training your model, modeling happens there, right? You update your model with this new information. So you can course correct the model as you move along.
So you're doing the evaluation of how it's doing?
Yeah.
Okay.
So this is all auto. So these all steps can be automated in our system. So you can have everything automated, like business understanding, and also you can have a feedback loop. So you see, one thing is important here. So see, all those things are feeding into each other. If you see, there are a lot of back and forth that happens. So you can have a new business understanding. Suppose, let me give another example. Right now, so